So let's just remember how to graph tangent. So I want to point out that when we're looking at this number in front of tangent, that's our amplitude. The number in front of the bubble is going to affect our period, but this time it's pi divided by b, not 2 pi. When we add c, we move it to c places to the left. And when we add d at the very end, we're moving it up d units. Now, the biggest change here is the fact that tangent has asymptotes. And in order to find your asymptotes, what you're going to do is you're going to take this part of your formula, of your equation, you're going to take that part, and you're going to set it equal to pi plus 2 pi n over 2. Now that n value, this n value, is just saying which asymptote are you looking for. You're looking for the first one, the second one, the 0th one, the negative first one. Which one are you looking for? So you get to plug in values for that. Typically you plug in -1, 0, and 1. So what's going to happen here is I'm going to give you an example. And what I want you to do is I want you to hit pause after you see the equation. I want you to try to graph it yourself. And then if you get stuck or if you're done and you want to check, then just hit play and you can see how to do it in the answer. So I'll give you 2 tangents, then I'll send you another video that has 2 cotangents. So let's do this one. 1/2 tangent of 2 times x plus pi minus 1. So I'm doing everything in here so we can see a complicated one right up front compared to the ones you had on the other video. And so I can start with my little notes that I make, right? My amplitude is going to be 1/2. This is kind of quotations amplitude though, remember. Tangent goes all the way up and all the way down. So amplitude is more like where's that next critical point. Our period is going to be pi divided by b, and b is 2 here. My phase shift is going to be pi to the left, and my vertical shift is going to be 1 down. Now the other thing I have to do before I can start graphing is find my asymptote. So I'm going to take this right here, and I'm going to set it equal to pi, so I've got 2 times x plus pi, setting it equal to pi plus 2 pi n all over 2. So first things first, remember our whole point here is to solve for x, so I need to first get rid of the 2 that's there, so I divide by 2. That's the same thing as multiplying by 1/2. So now I have x plus pi equals pi plus 2 pi n over 4. Still I'm solving for x, so I have to get rid of a pi, so I subtract pi on both sides. So this will be x equals. Now when I subtract pi, I want to include it in the rest of that fraction, so I need a common denominator of 4. So it'll be 4, let's see if I can squeeze that in there, 4 pi over 4. So when I put that in there, I'm going to combine this 4 pi with that pi right there. I can't with this one because of that n on it. So pi minus 4 pi gives me -3 pi plus, I still have the 2 pi n all over 4. So to find my asymptotes, I pick different values for n, so -1, 0, and 1 are typically the ones that I pick. So if I plug in -1 for n, I will get a -2 pi here. So -3 pi minus 2 pi is -5 pi over 4. Then if I plug in 0, that's going to completely go away, so I just get -3 pi over 4. And if I plug in 1, this will just be 2 pi, so -3 pi plus 2 pi is -pi over 4. So now to graph, let's see here, those are all negative numbers. So I'm going to put my x-axis to the left side of the y-axis, and my shift is down 1. So let's go like this. Alright, so my asymptotes are at -pi over 4, and then -3 pi over 4, and then -5 pi over 4. Now don't forget that I also have this shift of 1 down. I'm going to go down to -1, and that's going to be my new axis that I'll be basing off of. Also, my amplitude, air quotes here, amplitude is 1/2. So I will be going up to -1/2 and down to -3/2. Alright, so let's start graphing. Tangent hits the axis right in the middle in between the asymptotes. Remember, tangent's going to go up. So at my quarter marks, I have to go up on the right to 1/2 now, or down to -3/2. Same thing on the next one at my quarter marks. And then I can graph tangent in. Alright, and so there's the graph of that one. Notice I really didn't go over here and use anything, but I still want you to make notes on that. And we can always double check that the period is pi/2, so from here to here I go 1/2 of pi, things like that. Alright, let's do one more example. Let's do negative tangent of 1/2 x. Oh, let's go x minus pi plus 1. Alright, so again, let's go through. Our amplitude would be 1. My period would be pi divided by 1/2, multiplied by the reciprocal would be 2 pi. My phase shift is going to be pi to the right, and the vertical shift is going to be 1 up. Alright, now for my asymptotes, I'm going to take this. So I have 1/2 times x minus pi, and I'm going to set that equal to pi plus 2 pi n over 2. So again, the first thing I need to do is get rid of my 1/2, so I'm going to multiply by 2 over 1. So those are gone, x minus pi on the left. On the right, these two cancels out, which is kind of nice, so I get pi plus 2 pi n. Now I'm going to add pi to both sides. So I get x equals 2 pi plus 2 pi n. So now as I plug in numbers, -1, 0, and 1, when I plug in -1, this is going to be a -2 pi plus 2 pi, that's 0. When I plug in 0, this cancels out, so I just get 2 pi. And when I plug in 1, I get 2 pi plus 2 pi, that gives me 4 pi. So as I draw the axes here, I'm going to want to make sure that I put the x-axis all on the right there. I should have maybe moved that up. I wonder if I can move that up. Not really. Okay, so then now for the asymptotes, I have asymptotes at 0, at 2 pi, and at 4 pi. Alright, now I have a vertical shift of 1 up. I suppose I need a label, 0, 2 pi, and 4 pi. Okay, now tangent crosses the axis right in the middle of the asymptotes, so I'll put that point in there. Now, here's the tricky part. At my quarters, my asymptote, or my amplitude here, I have a negative there. So the number is 1, so I'll be going up to 2 and down to 0. But here's the deal. That negative is going to flip tangent. Now normally tangent goes like this, but if I flip it, that means it's going to be going like this. So when I'm putting in my next critical points, I need to put that one right there and the next one right there. Therefore tangent will be flipped, and it'll actually look like cotangent. Same thing here. And there you go, that's the graph of that one.